Section 5.1, angles. And these are the learning objectives. In this section, you will draw angles in a standard position, convert between degrees and radians, find coterminal angles, and also find the length of circular arc and area of circular sector. We all have at least a general sense of what an angle is. Below is a picture of an angle DEF. So this is angle DEF with a vertex E. We'll be commonly using Greek letters to refer to angles, and those letters include, the first one is theta, the second is phi, next is alpha, and this is beta, and this is gamma. To make things easy to read, we'll be drawing angles on an XY coordinate plane and in standard position. So this is in standard position, and that means that the vertex, like this one, the vertex is at the origin, and the initial side, like here, the initial side is located along the x-axis. So take a look at this angle here. This is in standard position. This is the initial side, and we have here as the vertex, and that is at the origin. And this is the terminal side. Alright, example 1. Let's draw some positive and negative angles in a standard position. We call these specific angles as quadrantal angles. First one, 90 degrees. So this is 90 degrees. Next one is 180 degrees. So from here to here, that is 180 degrees. Next, 270 degrees. From here to here is 270. And next one, 360 degrees. Here is 360 degrees. Next one, negative 990 degrees. Negative, that is clockwise. So think about, if it's clockwise, that is negative. Earlier was counterclockwise. And that's why it is positive. So clockwise is negative. So negative 90. So from here to here, so that is 90 degrees. Then negative 180. So from here to here, that is negative 180 degrees. Next, from here to here is negative 270 degrees. And from here to here is negative 360 degrees. Okay. Next one, example 2, label all of the following angles. So make sure to know your angles and immediately start remembering where the angles are. So we have here 0 degrees, and then this is 30 degrees, this is 45 degrees, and this is 60 degrees, and then this is 90 degrees. So make sure that you know this this is from quadrant 1, this is quadrant 2, 3, and 4. So earlier we know that this is 180 degrees, this is 270, so 0, this is also 360 degrees. To get the rest, next one is from 60 to 90, that is 30 degrees, so this must be 30 degrees also, so 90 plus 30 is 120 degrees. Next one is 90 plus 45 is 135 degrees. And this one is, yes, it is 150. Next one is 210 degrees. One of my techniques here is, you know that the straight line is 180 degrees, just like this line here, that is, the angle is 180 degrees, right? So to make it 180, so what I do is 30 plus 180 is 210 degrees here, and then this one is 45. If I add 180, that's gonna be 225. This is 60. If I add 180, that is 240 degrees. 90 plus 180 is 270 degrees. 120 plus 180 is 300 degrees. 135 plus 180 is 315, and the other one is 330 degrees. Okay, so make sure again, please start remembering where the angles are. Next is converting between radians and degrees. We will most often use a different measurement scale for angles than angles, and we call it radians, and it's equal to the following conversions. So 2 pi radians is equal to 360 degrees. Pi radians is equal to, when we divide by 2, 360 divided by 2 is equal to 180. So meaning if we divide both sides by pi, 1 radian is 180 over pi, which is approximately equal to 57.3 degrees. So to convert from radians to degrees, so whatever that radian is, so let's say x, we just have to multiply this by 180 over pi. And when you do that, you'll be able to get that is equal to something degrees. And same thing from degrees to radians. So let's say y degree, so you just have to multiply this by pi over 180, and when you do that, you'll be able to get radians. Okay, so again, from radians to degrees, you just have to multiply it by 180 over pi, and from degrees to radians, that is pi over 180. So next, label all of the following angles in radians. So 0, alright, the first one, this is 30 degrees. So to convert 30 degrees, we multiply this by pi over 180. So that's gonna be 30 pi over 180. And we simplify, 3 over 18 is 1/6. So this is pi over 6 radians. So this is pi over 6. Next one, this is 45 degrees. We do the same thing, 45 degrees times pi over 180 degrees. So that is 45 pi over 180, and that is equal to pi over 4 radians. So this is pi over 4. Next one, this is 60 degrees. So 60 times pi over 180, 6 over 18 is 1/3, so that is pi over 3 radians. So pi over 3. And 90 times pi over 180, so that is pi over 2. And 10, 180, 180 over 180 is 1, so this is pi. This is 270 over 180 is 3 pi, 3 halves, so 3 pi over 2. And then 360 over 180 is 2, so this is also 2 pi. So 0, pi over 2 pi, 3 pi over 2, and 2 pi. And the rest, I'll let you convert that from degrees to radians. Okay, you should have here 2 pi over 3. This is 3 pi over 4. This is 5 pi over 6. This is 7 pi over 6. 5 pi over 4. 4 pi over 3. And 11 pi over 6. Example 4, convert each radian measure to degrees. Letter A, pi over 6. We multiply this by 180 over pi. So that is pi over 5, and 180 over 6 is 30. So pi over 6 is 30 degrees. Next, letter B. So 3 multiply again by 180 degrees over pi, and 3 times 180 is 540 over pi degrees. Or if you divide this, 540 divided by pi is approximately equal to 171.88 degrees. Okay. Example 5, convert each degree measure to radians. So A, 15 degrees, multiply this by, yes, pi over 180 degrees. And 15 over 180, that is 1/12. So the answer is pi over 12. Letter B, 126 degrees. Multiply this by pi over 180 degrees. And that is both divisible by 2, so 63 pi over 90, or this divisible by 9, so 7 pi over 10 radians. Okay. Next one is finding coterminal angles. Look at the two angles below, 140 and negative 220. Even though their measurement is different, they both ended at the same place. We say that those angles then are coterminal. The two angles are coterminal if they have the same terminal side. Since we can add or subtract 360 or 2 pi in radians to any angle and get back to where we started, every angle has infinitely many coterminal angles. Come up with two coterminal angles on your own and draw them on the coordinate axis to the left. Okay, so let's say an example, if I have 30 degrees here and coterminal, meaning have the same terminal side. If I look at clockwise from here to here, that is negative 330 degrees. So 30 degrees and negative 330 degrees have the same terminal side, so they are coterminals. Okay, so example 6, find the least positive angle that is coterminal with 800. So the easiest way to do this for letter A is, given 800, you just have to subtract 360, and 800 minus 360 is 440. Again, we can subtract this by 360, and 440 minus 360 is 80 degrees. And if we continue that, 80 minus 360 is going to be negative 280 degrees, but we want positive angle, so you don't need to do this. So 80 degrees is the same thing as 800 degrees. So that letter A so this is an example that is 80 degrees. It's a coterminal with 800 degrees. Letter B, 870. Let's do the same thing. 870 minus 360 is equal to 510. And again, if we subtract 360 is equal to 150 degrees. And where is 150? 150 is like here. So this is 150-degree angle. Letter C, do the same for -45. So -45, this time let's add 360 degrees, which is equal to 315. So where is 315 degrees? That's 315 is this. So this is 315 degrees. Coterminal with -45. Okay. Next, arc length on a circle. We all know that perimeter of a circle is given by a circumference and we know that the circumference is equal to 2 pi r. What about the perimeter of a smaller part of the circle? We call that length as an arc, or simply the arc length. Arc length on a circle, in a circle of a radius r, the length of an arc is subtended by an angle with a measure angle in theta in radians shown in figure 21 is equal to this. And note that angle must be in radians. So arc length on a circle is this part here. Oops. So that small portion. And again, it only works when theta is in radians. So example 7, find the arc length on a circle of radius 10 when an angle of 215. So radius is equal to 10. So S is equal to 10 times the angle, and take note of this, that angle must be in radians. So we have 215 here. Let's convert that to radians. So 215, we need to multiply this by pi over 180. And if we simplify this, this is 43 over 36 pi. So we're going to use that. So 10 times 43 pi over 36, and that is equal to 215 over 18 pi. So that is the arc length. Okay, next, area of a sector. We all know that the area of a circle is given by area is pi r squared. For a smaller portion of the circle, like the slice of a pizza, the area of the sector is given by the formula A is equal to 1/2 times the angle r squared, and the theta must be in radians. So your angle must be in radians. So here is the area is 1/2 of the angle r squared, and we want to get this part here. So an example, an automatic lawn sprinkler sprays a distance of 20 while rotating 30 degrees. What is the area of the sector of grass that the sprinkler waters? The distance of 20 feet meaning radius is equal to 20. So it looks like this, and the distance is 20, the radius is 20, and we want to find this area, and the formula is 1/2 times the angle r squared. R squared is 20 squared. But what is our angle? What do we have here? 30 degrees, and remember, it must be in radians, so we need to convert this to radians. So 30 degrees, we multiply this by, remember, pi over 180 degrees, and 30 over 180 is pi over 6. So our angle is pi over 6. So let's multiply. 20 squared is 400 over 2 is 200. 400 over 2 is 200 pi over 6, and 200 over 6, they're both divisible by 2, so this is like 100 pi over 3. So this is the answer. Okay. Alright, let's try this time some lecture questions. For the following exercises, refer to figure 25 and round to 2 decimal places. 22 and 23. 22, find the arc length, and 23, find the area of the sector with the radius equals 3 inches and the angle is 140. So first, let's convert 140 degrees into radians. So meaning we need to multiply this by pi over 180 degrees, and 140 over 180, that is 14 over 18, they're both divisible by 2, so 7 pi over 9. And find the arc length, number 22. Remember that is S is equal to the radius times the angle. The radius is 3 times 7 pi over 9, and 3 over 9 is 3, so that is 7 pi thirds inches. Then 23, we want the area, and the formula is 1/2 times the angle, which is 7 pi over 9 r squared. R is, the radius is 3, so 3 squared. So that is 3 squared is 9. 9 over 9 is 1, so this is equal to 7 pi over 2 area, that is square inches. Okay, next problems. Letter A, convert the angle below from degrees to radians. So negative 315 degrees, we multiply this by pi over 180 degrees, and it's going to be equal to negative 7 pi over 4 radians. Letter B, 11 pi over 6 radians, convert this to degrees. So 11 pi over 6, times 180 over pi. So pi over pi is 1, 180 over 6 is 30, times 11 is 330 degrees. Okay, and that's it for section 5.1. Let me know if you have any questions, and thank you.